So in this video we're going to go through some more examples of factorising into a single bracket, and now I'm going to introduce a second variable. So xy plus y is our first example. Now remember, the way that I've been laying this out when we were looking at x squared or x cubed was I was thinking about, rather than writing x cubed, I was writing x times x times x. So here I want you to think about xy as x times y. Okay? Now, I've been training you to try and look for the coefficient first. Now, the coefficient in both these cases is 1, so we don't need to worry about anything there. So the next stage is looking at what factors they have in common. Now, both of these two terms have y in common, but they don't both have x in common. Okay, so because x is not here, but it is here, x is not a factor of both of them, so I cannot factor x out. But y is a factor of both, so I can factor y out. So y is what is going at the outside of my bracket. xy divided by y would be x, y divided by y is 1. And so y times x plus 1 would be my fully factorised form. Now let's take a look at number 2. We have xy squared plus y. So x times y plus y. Now, the coefficients are both 1, so we don't need to do anything there. This term doesn't have x involved, so x is not a common factor. But they both have y involved. So I can factor y out of my single bracket. Now what would be left? Well, xy squared divided by y would be xy. And y divided by y is 1. So this would factorise to xy plus 1. How about number 3? X squared y squared plus xy. So we have x times y plus x times y. Now both of those terms have an x in common, and both of them have y in common. So xy, x and y can both be factored out. So x squared y squared divided by xy would be xy. And xy divided by xy is 1. And so this is the fully factorised form. So sometimes you might find that this, writing it out like this, makes it more apparent as to what my highest common factor will be. But we do want to get to the stage of not having to do that. Okay, but if you need to do it at the start, that's perfectly fine. So number 4, 4xy squared take away 8xy. So let's see if we can do this without writing it all out. Now, these have the coefficients of 4 and 8. So the highest common factor of 4 and 8 is 4. So that comes out. They both have x in common. So x can be factored out. And they both have y. Okay? And we're looking at the smallest power of y, so y to the 1. I can factor that out. So 4xy squared divided by 4xy would just be y. And then 8xy divided by 4xy would be 2. So minus 2. Okay, and so that's my fully factorised form. Now the last one, we have 5x squared y squared take away 15x squared y. Now I will write this out, okay, just so you can see it longhand. So we have 5 times x times y times y take away 15. Now, 5's prime, so I'm going to write 15 as a product of its prime factors, which is 3 times 5. And then we've got x squared y. Okay? So we're looking to see what's common. Well, the highest common factor of 5 and 15 is 5. And that's given by the fact that they both have this 5 here. Then we've got an x squared here and an x squared there. So I should be able to factor out x squared from both. They both have that in common. So they both have an x. In fact, they've both got x squared. And then I've got y squared and y. Well, the highest common factor of those two would be y. They both have a y in common. So what's left? 5x squared y squared divided by 5x squared y. Well, that's just y, which is there. And then 15x squared y divided by 5x squared y would just be 3 minus 3. And that's that term there. Okay, so you can see that separating it out like that can be very helpful, especially if you're a little bit unsure, but you do have to write the coefficients as a product of its prime factors, really, in order to kind of help you through that process. But if you're happy about spotting the highest common factor of the 5 and 15, or the 4 and the 8, then you should be on your way.